Fine. So, what are we going to learn today? I sent a message few minutes ago because none of you had asked for any particular topic. So, I'm just going with the flow. Unit 12 of Digital's SAT Prep Isha that we had started. I'm just continuing with that. I was just checking that I think we started with rational expression and we kind of stopped somewhere halfway through. So we'll probably spend some time on that one, complete that chapter, particular section, and then we will go to next topic, which was again something that we did before, operation with polynomials. So I think we have done that. We'll just do a quick recap and then tomorrow onwards we'll continue with the remaining parts of that unit. Is that okay with everybody?
Yeah.
Okay. And I would request you guys to be on video, okay? The reason being, it actually helps me make eye contact with you guys and then probably talk to you and see your expression, see your confidence, see if whatever I'm telling is reaching you guys or not, okay? So if you can be on video, that will be even better. I mean, I would rather request you to be on video, so that way I can see how my kids are, okay? Wonderful. Thanks, Pranit. So, unless you are in a situation where you are not comfortable being on video, I would suggest you to be on video, okay? All right. So, first of all, what is a rational expression? What is rational exponents? We are talking about rational exponent and radical exponents, not expression. And then we will talk about the dealing with operation with polynomials. So, what is a rational exponent? What do we know by rational? Any guesses? Think about it. Let me turn on the fan. It's kind of getting hot. Yeah. So what is a rational exponent? What is rational, first of all? You guys always think too much. Don't think too much. Anything that can be written as a fraction. See, we say fraction. This is fraction. This is fraction. This is fraction. Yeah? They are all positive numbers. If you include this also to the group, the whole group together is called rational number. Like, okay, I think somebody went missing, came back again. Okay, fine, I will just check. So, like we know, a natural number and a whole number are only 0 and positives, and if you add negatives to it, that makes it integers, right? Same way, here, when you're dealing with fractions and you include the negative fractions also, that group together is called rational number. Yeah? So, without complicating it much, if anybody says rational number, you can safely assume that that person is talking about fraction. Yeah? So, we will keep on using the term rational number and fraction interchangeably. Yeah? Everybody with me? Okay. So now, when you talk about rational exponent, we know exponent for sure. Yeah? What is a rational exponent? What is so rational about an exponent? What is exponent? Exponent. 3 to the power 2, meaning 3 into 3. This is called exponent. X to the power 5, meaning x into x into x into x into x 5 times. This is exponent. Yeah? This is the exponential form, which is where this is a base and this is the exponent or the power. Yeah? Everybody with me so far? We know what is exponent? Now, when you say rational exponent meaning exponent where the power is like a rational number. So, now let's look at what would be a rational exponent then. So, this is one exponent, 3 to the power 4. Now, 2 to the power 1 by 2. Life gets more interesting. Yeah? So, here, this is the number, the base, and the power on that is a rational number, not a natural number, not a whole number, neither an integer. If somebody would have said 2 to the power minus 3, what we have learned is, oh, this means 1 by 2 to the power 3. We are just moving it downward, right? But when power is half, 1/3, 2 7, 7 9, what does it mean? Sorry? A little louder for me. Bhavam, you were saying something.
It's a rational exponent.
Rational exponent. This is called rational exponent. What does it actually mean? Now, I'll give you a very bad theory, okay? Bad but easy to remember theory, okay? Now, this is 2. What is this? This is inverse of 2. Yeah? Now, look at this. 2, this is one number, exponent, 2 to the power 2. Now, this is inverse or rational number. Or in other terms, this is reverse of what a power of 2 could be. 1 by 2 is reverse of what the power otherwise would be. This is reverse of this. Or I can say it like this. This is 2 to the power 2. If I say find out the square root of, then when this sign is called radical. Okay? So, when you say rational exponent or radical exponents, these are similar stuff but represented in two different ways. Okay? So now let's look at it. 2 to the power 1 by 2 is nothing but the square root of 2. If I say 3 to the power 1 by 8, what does it mean? 8th root of 3. So let's not make it so complicated. Let's look at a simpler thing. 9 squared is one exponent. If I say 9 square root or 9 to the power 1 by 2, both are the same. If I say 27 to the power cube root of 27, or I say 27 to the power 1 by 3, or the same. So whatever you see the denominator, that is the root version of it. Whatever you see in the denominator, that is the root version of it. Okay? Now let's play with this, because learning math will be incomplete if you don't play. Now I'm saying find out this. Can anybody tell me what is the value of this? 9 to the power 1 by 2. What is that I'm trying to find here? Square root of 9. Whatever is my denominator, that is the root I am trying to find here. Okay? Now, let me make it a little interesting and easy for you guys. So, if I have something like this, 9 to the power 1 by 2. Now, you guys know 9 is 3 square. Is it the same thing? I wrote 9 as square of 3. I put that inside the bracket, and then whatever power I have put it here. Is this okay? Everybody. Vaibhav,
Oh, yeah.
Atharv, Isha, everybody. Yeah? And I will not let you go unless you guys say yes. Or till you guys say yes. Even if that requires me to explain this 3 times, I'll do it. Okay? Now let's look at the interesting part of it. Why this exponent helps. Why the rational exponent helps. Now, another thing we know is 2 to the power 3 to the power 2. How much is this one? Do you guys remember? 2 to the power 3 in bracket and to the power 2. How much that is? If you recall, x to the power m to the power n. It is x to the power m into n. Remember? In exponents, there are 3 things that we have learned. Let me repeat it for you guys and then we'll come back here. X to the power 2, x to the power a into x to the power b. It becomes x to the power a plus b. X to the power a divided by x to the power b. It becomes x to the power a minus b. And x to the power a to the power b, this is x to the power a into b. Here are the three formulas that we have proved while we were trying to learn exponents. Just try recalling it. And if you are not able to recall, I will help you guys. X to the power a multiplied by x to the power b. That gives me x to the power a plus b. Remember? Everybody remembers? Atharv, Vaibhav. You were not there, but I'm just trying to see if you were knowing it before.
Oh, yeah, I know.
Or I can, okay. Let's spend 2 more minutes. I know that you guys need to be up to date with this one. If I say x to the power 1 into x to the power 3, it becomes x to the power 1 plus 3. You will ask me why? Because x to the power 1 is x, into x to the power 3 is x into x into x. How many x we have now? X to the power 4. 1, 2, 3, 4. What happened? These two got added. That's what the theorem is. Yeah? Now, second one is x to the power 2 or x to the power 4 divided by x to the power 2, or let's say x to the power 5 divided by x to the power 2. What I was saying was, this will be x to the power 5 minus 2. Now how? let's see this. X to the power 5 is 5 times x. My x squared is 2 times x. Tic-tac-toe, this gone, this gone. How many x you are left with? 3. So that is x into x into x. That is equal to x to the power 3. Yeah? So this theorem is also right. We will just, whatever is the power of the numerator minus the power of the denominator, the base is same. Okay? Now the third theorem was x to the power a, or let's see this, x to the power 2 to the power 4. I was saying this will be x to the power, if you have a power inside the bracket and then you have power outside the bracket, this becomes this into this. Now let's try that and try proving it. X to the power 4, what does it mean? It means x squared into x squared into x squared into x squared, 4 times. Oh, sorry. 4 times. Or you can further break it. X squared is x into x. Or you already know that x squared into x squared. So you will add these two powers. So this becomes x to the power 2 plus 2. Similarly, these two also you can multiply. It becomes x power 2 plus 2. X power 2 plus 2. That equals x to the power 2 plus 2, 4. Into x to the power 2 plus 2, 4. This equals again, we are multiplying the same base, x to the power 4 plus 4. It becomes x to the power 8. Is this not same as 2 into 4? Yeah? Is everybody with me? I hope I'm not talking to myself. Yeah? Alright. So, these are easily relatable rules, but it's very important for us to always remember due to practice, okay, that x to the power a into x to the power b, my base is same, my power gets added. X to the power a divided by x to the power b, my base is same, the exponent gets subtracted. X to the power a to the power b, my power gets multiplied. Okay, this should be like, memorizing table. Okay, like we know 9 7 are 63, that will never change. These are the things that becomes like things that you end up memorizing with lot of practice. Okay, I mean I don't think I have memorized these formulas, just that I have practiced enough while I was a kid like you guys, or now while teaching you guys. So I don't have to memorize it, I just know it. Yeah. Now coming back to the problem that we were trying to solve, 9 to the power 1 by 2. Yeah. I was saying, okay, it's power 1 by 2. Let's not get into the problem of square root, cube root. Let's do basic operations and see if we can solve it. 9 is what? 9 I can always write as 3 to the power 2. Yeah? So far so good. I'm not changing anything. I just wrote 9 as a square of 3. That's it. Yeah? Now you try relating this with this formula. Does this not look similar to this? Does this guy not look similar to this? 3a, if a is 3 is x, a is 2 and b is 1 by 2. Yeah? Now I can use this formula because I know it. I will say this equals 3 to the power a into b, a into b. What did it become? Tic-tac-toe. 2 into 1 by 2 will give you 1 only, right? Yeah? 9 to the power 1 by 2 became 3. And did you guys notice how it became? Whatever we had learned with exponents, we just applied it. Okay, So I must be looking like the roadside laborers, right? Who are working in sunlight and they're always sweating. So it's okay. Today, if you guys are learning something from a laborer, that's fine. Yeah, that's perfectly fine. It's summer. Summer is going to remain like this. So coming back to this one, look at this. This one was looking very complicated. 9 to the power 1 by 2. When we simplify this, actually it became simple. Yeah. Now let's look at one more problem. Okay. I should not have deleted that, but that's okay. Can you guys find out what is the value of this? 16 to the power 1 by 4. And this is, I'm not checking you guys, I'm checking myself whether I was able to explain that to you guys okay or not. 16 to the power 1 by 4. Who can find it quickly for me?
4.
Say it again.
4.
No, don't rush.
2.
Yes. Okay, so now let's look at it. 16. I can write as 16 is 2 times 2 times 2 times 2. 2 times 2 4, 2 times 2 8 times 2 16. That is 2 times 2 to the power 4. Okay? Now this is the equation where we are saying x to the power a to the power b. So that becomes x to the power a into b. Yeah? And then comes tic-tac-toe. Yeah? Now let's can somebody solve this? 25 to the power 2 by 4. And you will be able to solve it if you consider this is an easy problem. You will get stuck if you consider this is a tough problem. Let's see who all can solve this. 25 to the power 2 by 4 or forget it, 2 by 4. Yeah, fine. Actually, I am giving a very, very easy problem. I should have given something different, difficult. Yep. Yeah, Pranay. Five. Okay. So as soon as I have got one answer, everybody has got similar answer, or you guys got different answers? Anybody got different answer than 5? Sorry, sir?
I got the same answer.
Same answer? Okay, so here's the thing. 2 by 4, you can always simplify this. It becomes 1 by 2. So that would have essentially meant square root of 25. Or in simple terms, you will say, okay, fine, 25 I can write as 5 square to the power 1 by 2. And then this becomes x to the power a into b. So 5 to the power a into b. That is how it works. if you have to find out, there is one more question that I've written, one last question before we move on. 7 to the power 3 by 7. Who all can find it? 7 to the power 3 over 7. And don't spend more than 2 minutes, okay? Because this problem is only to get your concept right, not to solve. I don't think anybody in this classroom can solve and get an exact answer, okay? Including myself. Okay. Diamonds. Okay. So here, I'll tell you why. What is that I was wanting you guys to do here, okay? If you look at a number like this, what is your understanding? Oh, this is something that can be written in a radical form also. This is cube root of 3. Yeah? So, what it means is 3 to the power 1 and then this many roots. Here if you see this one, 7 to the power 3 by 7. What does it mean? 7 to the power, here you have 1 by 3, so 3 to the power 1 and cube root of that. Here if you see, 7 to the power 3 by 7, what does it mean is 7 to the power 3 and 7th root of that. So you can as well write this as 7 to the power 3. Okay? Or what it means is 7 to the power 3 is 7 into 7 into 7. 7th root of that. So this will be 49 into 7. 49 into 7. 53, 7, 28 plus 6, 34. 7th root of 343, that's what the answer is, okay? I'm not going to the fractions, decimals and find out what is the exact value for this one. But I was just trying to tell you guys that this is the understanding part of it. If you have a number like this, then you know that this to the power this and this is the cube root. So 3 to the power 1. So likewise, if you look at this, when I was saying this one, we had the option of simplifying this and saying 2 by 4 becomes 1 by 2. But if it was, let's say like 2 by 3, that means 25. Whatever is the numerator goes here, whatever is the denominator, that is the root number. Okay? Are you guys with me so far? Yeah. So now let's look at some basic quick operations, okay? And then we'll go to the next topic. So if let's say you have 5 to the power 2 by 3 into 5 to the power 1 by 7, how much that will be? 5 to the power 2 by 3 into 5 to the power 1 by 7. Here I am multiplying rational exponents. Isha, Athar, you guys are very quiet.
Just 1 3.
What is that, beta? Say it again.
It's 5 to the power of 1 by 3.
5 to the power 1 by 3. It cannot be.
5 to the power of 17 to the power of 31.
17 to the power over?
17 over 31.
Yes. Yes, you're right. So, did everybody get that?
Yeah.
So it's simple thing, okay? So you are multiplying 2 with the same base. So what happens is this becomes this plus this. And then you all know how to do add the fractions and find it out. Now, same way, if somebody says 25 to the power 1 by 7 divided by 25 to the power 1 by 9. Same way, you will do what? X to the power a divided by x to the power b becomes x to the power a minus b. So here also the subtraction comes into play. So this will become 25 to the power 1 by 7 minus 1 by 9. Yeah? This part is okay? Everybody with me? Now, so I'm not going to teach you guys anything about the radical expression because it's the same thing as rational expression, just represented in a different way. Okay? If I say 5 to the power 1 by 7, this is the rational expression, and 7th cube of 5, this is the radical expression, radical exponent. So this same thing, radical exponent and rational exponent are the same thing. They are just represented in a different way. That's it. Okay? So I'm not teaching you guys anything different with respect to radical exponents. Okay? It's the same stuff. Yeah? Okay. Now, one more question. 25 to the power 5 by 7 plus 5 to the power 2 by 9. Who can add this for me? One last question. 25 to the power 5 by 7 plus 5 to the power 2 by 9. Get me the most simplified form. You don't have to give me exact answer, okay? The most simplified form. Say that one more time, Babu.
It's 5 square root 25 over this power.
Can you write in the chat? Can you write in the chat here? Or if you have written in a piece of paper, you can show it to me. Anyway, it's fine. Do you guys play outside in the sunlight when it's very hot? No? No. I used to play, I mean, not I as an I, kids of my generation. I mean, many of your parents also would have, many of the parents of u. Okay. Or I don't know what is the right sentence. Okay, I'm getting stuck. So I'm saying most of the parents, for you all, okay, they would have played in sunlight, like in a very hot weather. So that's why I'm able to stand that hot temperature. But yeah, it's kind of very sweaty. Anyways, coming back to an interesting news, right? Who all saw India winning the World Cup today? Wonderful. Praneeth, do you know India won the World Cup? No? We did. Isha, did you?
Yes.
Oh, wonderful. Yeah, I was talking to Daddy today morning, and then he reminded me, are you not watching the World Cup? I said, no, I don't watch the whole match. Rather, I just look at the highlights. So that's what I did. And good news is India won. Anyways, coming back to the class. So, who all got the answer for this one? Praneeth got, okay. Atharv also got. How much was that, Atharv? Atharv, you might want to unmute yourself and tell me how much is your answer.
5 to the power 185 divided by 62.
5 to the power 185 divided by 62. Is that what you got, Vaibhav, as well? Now? Okay, so let's try solving it together. I know most of you would have solved, but let's try finding out what we are trying to do. And we'll apply all the things that we have learned. Okay? 25 to the power 5 by 7. And here we have 5. So when we do maths, right, one theory that we have to apply is always try simplifying it. Anything that looks bigger, complicated, make it smaller. Now, here you have a 5 to the power something. Here you have 25 to the power something. I'm not liking apple and oranges together. Let me convert everything into an apple or everything into oranges. Okay? So now let's look at this. 25 I can write as 5 square. Whatever I have. Yep. And then 5 to the power 2 by 9. See, here it was to be complicated. 5 to the power 25 to the 5 by 7. 5 to the power 2 by 9. It was really complicated, but as soon as you did this, now this looks more friendly, right? Much easier. Let's see. Now, this is the form of x to the power a to the power b. So it becomes x to the power a into b. So it will become 5 to the power a is 2, into b, 5 by 7, plus whatever it is here that remains as is from now on. So this is 5 to the power 2 into 5 by 7. So that means this equals so this became 5 to the power 2 into 5 by 7. That meaning 2 5 are 10 by 7 plus 5 to the power 2 by 9. Yeah? Everybody is with me so far? Okay. Now this is a simple thing. 5 to the power 10 by 7, 5 to the power 2 by 9. Here, okay. Now, you will try finding out what is common here. So, 5 to the power 2 if I take common, okay? Then what I am left with here is square 5 by 7. This is what it becomes. Yeah? And here it becomes 2 I am taking out. No. This is not the case. No. This will not be the case. If I have to take 5, 10 by 7, 5, 2 by 9. I am myself getting stuck in this math. Okay? So how much I can take out? I can say Okay, so here is the thing, okay, yeah. So when you have, I will not going to do it like this, okay. 5 to the power 10 by 7 plus 5 to the power 2 by 9. Now, which one is bigger? Which number is bigger? This one, right? Which value is bigger? 10 by 7 and 2 by 9. Which one is bigger? 10 by 7, right? So what will you do? 10 by 7 minus 2 by 9. This is what we will do. Okay? Let's find out how much is that. 63. 7, 9, 9 to 10, 90. Minus 7 to 2, 14. So it becomes 76 by 63. So here, what it means is, see what I'm trying to do is, this number is bigger than this. How much bigger? This is the difference between these two numbers, okay? So I can write 10 by 7 equals 2 by 9 plus 76 by 63. Do you guys agree or you don't? I subtracted this number from this, okay? And I got this value. So I'm saying that means this number equal to this plus this. Yeah? And why I'm doing that? Because when I'm trying to take something common out between these two numbers, okay? So you can stop here also. Okay, so let me write it. 10 by 7 equals 2 by 9 plus 76 by 63. And I'm sure everybody is confused right now, okay? Because I'm trying to rewrite something on the fly. Okay? Now, here's the thing. What is that I'm trying to do? We are trying to add these two numbers, okay? Where my base is the same, but my exponents are different. And we know that x to the power a into x to the power b equals x to the power a plus b. Okay? So I am trying to break this into a and b, where one is this and b is something else. Okay? So now you know that 10 by 7, we found out 10 by 7 equals 2 by 9 plus this. So I will say 5 to the power 10 by 7 is meaning 5 to the power 2 by 9 into 5 to the power 76 by 63. I am just breaking into two parts. And now when you see me doing this calculation properly, then you will appreciate what I am trying to do. Okay? What did I do? I had this number and I had this number. These two numbers were to be added. And I know that this number is bigger because 10 by 7 is always going to be bigger than 2 by 9. So I found out the difference between these two. And whatever was the difference, I can just split that into two parts. Okay? And now, with this being the case, this one is common in both of them. This is my most simplified form. Trust me, they are not going to ask you this question in SAT, okay? So don't be scared. I'm saying just look at the approach that I have taken, okay? And this approach is not to be gauged based on the bigger numbers that we are dealing with, just the approach, okay? Now, let's look at what did we do so far, okay? Let's do a quick recap of that. We had a number like 25 to the power 5 by 7, and other number was 5 to the power 2 by 9. So first thing we did was we converted this into the form of 5, so that I had something similar looking like. And then I know that 5 to the power 10 by 7 and this one, there is no way I can add. When we have to multiply, the power gets added. When we have to divide, the power gets subtracted. When we have to do a power of power, the power gets multiplied. But here we are simply adding this thing. Yeah? We are simply adding the exponents. Okay, let's do a simpler sum. I think you guys are right now worried. Okay, let's look at this. If you have to add this, what will you do? 3 to the power 5 plus 3 to the power 2. What will you do? You know that okay, 3 to the power 5 I can write as 3 to the power 3 into 3 to the power 2. Yeah? Plus 3 to the power 3. Now I can take this part common. So this becomes 3 to the power 3 common. Here 3 squared plus 1. So far this is okay? Yeah, everybody? Now this becomes 3 cubed into 3 squared is 9 plus 1. It becomes 3 cubed into 10. Yeah? That is what you will do. So when you have to add exponents, what you have to do is you have to take the common things out and then you will be able to do it. Or you find out the value of this and find out the value of this and add them together. Or you take the common things out and then use that, right? Atharv and Isha. Since I'm not able to see you guys, I don't know I can't see your expression. I'm not sure if I'm sounding confident to you or if you are sounding confident or not. Are you okay? Sorry, beta?
Why couldn't we add 5 plus 3?
We cannot. We will never ever add them. Now I'll tell you why. So that is why I want to see the question mark on everybody's face. That is when it gives me the opportunity to. So these are very minute details of maths, okay? And one small oversight can get the question, get the answers wrong. Now let's look at this. Are these same questions? No. So that is what you have to be very, very careful about. If it's a plus or it's a multiplication, it will change life upside down. So whatever you were saying, that will be perfectly fine when we do this. Okay? Because if you do 2 to the power 3 into 2 to the power 2, it becomes 2 to the power 3 plus 2. This part is okay. This is the normal exponent thing, which we are very comfortable doing. Okay? Because the power gets added. Here, it's a different situation altogether. Right? So just be little careful there. And I would not be, what do you call? I'll not be even hesitant to say that this is something that I've seen people committing mistakes even when they are doing graduation. Okay, you guys are much younger still. Because this is it's a very tempting problem. It will make you, if you just ignore it for a second, you will go wrong. Okay, so coming back to this one. So here, when you have a situation like this, when you are adding the numbers, the only way you can add them is find out how you can break into two fractions, make it like A into B, and this is, let's say, A. Then you can take the A's common out and then become A into B. Yeah? Yeah? Same thing applies for subtraction also. So let's say somebody says 2 to the power 81 minus 2 to the power 76. Okay? So here, what will happen is, Here you know 2 to IT1, I can write as 2 power 76 into 2 to the power 5. We just split that to 2 parts so that we can take common things out. Yeah? So here, first guy has 76 at 2 power 5 and this guy has only 76. So now you can take 2 to the power 76 out as a common step. Yeah? It's like we are creating fractions. We are creating, not fractions, we are doing factorization. We are trying to convert from a plus b or a minus b into something like multiple of two things. Okay? Yeah? So, good that I kind of thought about doing this one, because in all the classes I remember I have taught everybody exponents, how to deal with exponents, multiplication, division and power of power. But then addition of sub components, be it rational or irrational, rational or normal exponents, we have not done that. So now let's go back to the problem that we were trying to solve. 5 to the power 10 by 7 plus 5 to the power 2 by 9. Now if you guys come back to this one with whatever we have done, we know 10 by 7 is bigger than 2 by 9. So this number is bigger than this number. Okay. What we are trying to do is we are trying to break this into two parts so that one part is equal to this, so that we can take that out as a common thing. So that's why if you remember what I was doing was, let's subtract this value, this value from this one. This gave me 63, 7, 9 is 63, 9 to 10, 90. Minus 97 is 67, 22, 14. It becomes 76 by 63. So that's why I said, okay, I can break this into two parts as 5 to the power 76 by 63 into 5 to the power 2 by 9. Because 10 by 7 minus this gives me this. Meaning this plus this equals this one. So this equals this plus this. So I broke it down to two parts. Now second one is 5 to the power 2 by 9. So I have one thing which is common between both the terms. This term is this common. This is common in this term and this term also. So I can take this thing out as common, and this becomes 5 plus 76 by 63 plus 1. So that is the reason why I was subtracting the power to find out how do I break it down. Now that gives us one theory, right? See, there are a lot of theories that we will end up deriving for ourselves, okay? Which is not going to be there in any of the books. Now let's look at it. Let's look at what theory we have derived today as a group. Let's say if I have x to the power m minus x to the power n, if I have to do this, or if I have to do this also, any which way, and I am told that m is greater than n, okay? This power is greater than this. What that means? I will say I can break this as x to the power m minus n into x to the power n plus x to the power n. What did I do here? Everything is same. I am saying this power I broke into two pieces. X to the power m minus n and x to the power n, and this is already x to the power n. Yeah? This minus this is one term, and this is second term within this one. So now in the next step I can always take this guy out, and it becomes x to the power m minus n plus 1. And you don't have to memorize this formula. You have to just remember that, okay, fine. When I have to add two exponents, be it normal exponents or rational exponents, any which way, I will find out which exponent is bigger, which one is smaller. I will break the exponent into two pieces. One part of that will be the smaller exponent, Other part of that will be the difference between the two exponents. Yeah? That helps me split that into two parts. Is it making any sense so far? Are you guys with me?
Yeah.
Yeah? Now apply this formula in one problem, one easy peasy problem, okay? I have to do, let's say, x to the power 10 minus x to the power 10 to the power 6. What this means is, I said, I know this exponent is bigger than this one. So I will break this into two parts, where one part will be this and another part will be the difference of the two. So that will be 10 to the power 6 into 10 to the power 10 minus 6. Difference of the two. Yeah? Minus 10 to the power 6. Yeah? So now, you know that, okay, fine. It becomes 10 to the power 6 into 10 to the power 10 minus 6 is 4 minus 10 to the power 6. See, you did not change anything. 6 plus 4 will become 10 only. We just found a way for ourselves in a convenient way to break into two parts, and now I can get the common thing out and I can do my calculation. So it becomes 10 to the power 4 minus 1. Yeah? This formula nobody is going to write for us, okay? We derived it for our practice, based on our practice, and we'll use that conveniently while practicing. So that way, we don't have to rely on anybody else. We don't need a book. We don't need a teacher. Yeah? Alright? Any questions so far? What? Srivatsav, Vaibhav, Praneet, Athar, Isha. Any questions? Any doubt? Anything that is bothering you? Huh? No?
No, sir.
No? Okay, good. Alright. So, here are the things that we did today, okay? One is, we learned what is a radical exponent and what is a rational exponent. And essentially both are the same. These are just two different ways of representing it. Okay? Then we learned how do we deal with radical exponents, rational exponents, how do we do calculation, how do we do multiplication, division, and then we also did addition and subtraction. And that is where we found out the new formula for us, where if we are doing addition and subtraction, we have to find out the common things among them and then factorize it. Yeah? So that is where we learned the formula again, or we derived the formula. I don't think this formula you will find anywhere. It's just something that we have derived for ourselves. Okay? And then the next thing that we were supposed to do was, this is something which we have already done. Okay? So this was, it was practicing dealing with polynomials. So polynomials we have already dealt with. We have learned what is polynomial. What do we mean by polynomial? When we say polynomial, it's nothing but an expression with multiple terms into it. Yeah? And then, how do we do operations with that? So, I think we have done that in the previous class, but since we are already top of the hour, we will probably not be able to cover that today. We will probably spend 5 to 10 minutes on that one to cover operation with polynomials, and then we'll go on to the next topic in Unit 12. Will that be okay?
Yes, sir.
Isha, Thar, Srivatsav, everybody okay? Oh. Okay, so that brings us to the end of the class. We will stop